Alright, for lesson 7.5 we're going to learn about some properties of logarithms. In our first property, we can expand a logarithm to be an expression of the same logarithm but in many logs. So they'll be added, subtracted, and we're going to also have multipliers, so like coefficients. Alright, and our second, we're going to take many logarithms and condense them into one log. And then we're going to use this guy to be able to evaluate something like log base 5 of 17 using a calculator. Okay. Alright, so here are our properties of logarithms. And what we can see is that if our base remains the same, base b in here, if you have two values being multiplied together, you can write the logarithm as an addition of two logs given two different values. So log of m times n with a base b is a log base b of m plus a log base b of n. And this similarly, if you can add two logarithms together that are multiplied, you can also condense to go backwards. And then our next property is the quotient property, where if you have two values divided by each other with the same base, the key here is the same base for both of these. You can then make it an expression of subtraction, or vice versa. If you're subtracting two logs, you can go back and condense it into one logarithm where the values are being divided. But again, the base has to be the same. And then the power property is where if you have a value that's being raised to an exponent, you can then bring that exponent down out in front and make it a coefficient of the logarithm. And vice versa, if you have a coefficient of your logarithm, you can bring it back up to make it the power of your argument, or your value. So using the properties of logarithms, we can also approximate logarithms here. Okay, using these properties, like I said, we're going to take the fact that since we're doing 3 over 7, you can say log base 5 of 3 minus log base 5 of 7, and then you can take those values, 0.683 minus 1.209, and you get negative 0.526. Okay? Or here we have log base 5 of 21. Well, what you need to see is that 21 is the same as 3 times 7. 3 times 7. So then I can say, well, that's log base 5 of 3 plus log base 5 of 7. And then I get to say 0.683 plus 1.209. And that comes out to 1.892. Okay. And then log base 5 of 49, what you'd have to see here is that 49 is 7 squared. So I would rewrite this as log base 5 of 7 squared, where I could rewrite that now as 2 log base 5 of 7. So I brought this down in front to get this new expression. So then I get 2 times 1.209, and that's 2.418. Okay. Alright, now we're going to expand. We're going to take this logarithm here, based on all of this stuff, and we're going to break it apart into multiple logarithms. So the general order is we always start with division first, unless there's a power that's outside everything. So if there had been parentheses there, you would bring the power first. Otherwise, we always start with division first and then go to the multiplication. Alright, so we go log base 2 of 7x cubed minus log base 2 of y. Alright, so we took this expression and that became our first logarithm, and then we took the second, the denominator, and made it our second logarithm. Now, you might be thinking, well, I could bring the 3 in front now of this logarithm, but the problem is that 3 does not affect our 7 here. Our 7 has an exponent of 1. So we need to separate the multiplication first. If there had been parentheses, you could go ahead and do that, but there hasn't been parentheses here. There wasn't. The cubed only works for the x. So we're going to say log base 2 of 7 plus log base 2 of x cubed minus log base 2 of y. And now last but least, we're going to bring this power down in front. And we're going to say log base 2 of 7 plus 3 log base 2 of x minus log base 2 of y. And we have our answer. Okay, we're going to do the reverse of what you just saw. So we have 3 logarithms here, and I usually work left to right. But I also need to start with my powers first. So anytime I see a coefficient, I need to bring that power up before I can add or multiply or divide or anything. So the first thing I'm going to do is I'm going to rewrite this as log 6 plus log of 2 squared minus log of 3. And here I get log of 6 plus log of 4 minus log of 3. And then now what we can do is we can take and multiply 6 and 4. So we can say log of 24 minus log of 3. And then we can say log of 24 over 3, which equals log of 8. And if you wanted to enter that into your calculator, log of 8 is roughly 0.903. Again, if you don't remember, if we don't have a base here, our base is 10. Alright? So either of these answers is just fine. Alright, now change of base formula. This is cool because we get to do any logarithm, any base, no matter what, as long as the value is a number and not a variable, then we can enter anything into the calculator. So if I take log base 3 of 7, that's going to be the same as log of 7 over log of 3. So what I've done here is I changed the base of my logarithm for the argument to be base 10, and I changed the base of a logarithm utilizing my other base to be my denominator. And then I can now enter these into my calculator because we have the logarithm button where we have a base 10, just like this. Again, if I don't write a base, my base is 10. So log 7 divided by log 3, and I get roughly 1.77. You could try this also with the natural log. So you could say log base 3 of 7 is equal to natural log of 7 over natural log of 3. You can choose any base you want to do the change of base formula. I could have said log base 5 of 7 over log base 5 of 3. But that wouldn't get me anywhere because I can't enter these in the calculator. I can enter log or natural log. And again, if I go ln of 7 divided by ln of 3, I get the same thing, 1.77. So in either case, remember our ln is just log base e, right? So we have the ln button and we have the log button, and we get to change whatever base we want to work wherever we want in this formula. So the argument or the value goes on top, and our original base becomes the value of our new logarithm on the bottom. Okay, last but not least, we have some other examples here to give you some practice. I would try these, maybe bring them to me in class or before school, or bring them to the math lab to discuss further. All right, hope that helped.